Good afternoon. Welcome. Welcome to this long title session, Design Pattern Practices Techniques with Windows, Azure, AppFabric, whatever. So, my name is Yuval Lowy. I'm a software architect. I'm the principal of iDesign. We specialize in .NET architecture. Personally, I've spent the last 4 years doing almost nothing but the service bus. It's been the focal point of my professional career. I think it's one of the most, if the most exciting technology to come out of Microsoft in a long time. Other things I do, I'm the Microsoft regional director for the Silicon Valley. I do not work for Microsoft, I work with Microsoft. Published a few books. My recent book, the third edition of Programming WCF Services, is about 40% content on the service bus. It has so much content we literally was considering changing the title, but we ended up just changing the tagline. Even though I do not work for Microsoft, I was privileged to be part of both the C# at the time and the WCF design effort. Published a lot of magazine articles. Virtually all my publications over the last few years for MSDN were about the service bus. Microsoft recognized me as a software legend, somewhat of a vain title, but if you need to get in touch with me, it's always going to be iDesign.net. That's about me. Let's talk about this session. This is about what you can do with a service bus. And I'm not kidding myself. I know that it's not real to assume all of you even know what the service bus is. And giving it a name that doesn't even fit, giving the technology a name that fits in 2 lines is not a good sign, right? So we're just going to call it a service bus. Now, I'm going to share with you a lot of techniques and ideas and things you can do and a way of thinking about what you can do with a service bus. And I'm going to have to assume that everybody in this room know WCF. Anybody here doesn't know WCF? Nobody? WCF cold? Good. So we're going to just go through a collection of ideas that I thought I can actually fit in 75 minutes. If we have time, I'll show you more. That's the plan. Okay? So what is the Windows Azure AppFabric Service Bus? It's something that grew organically. Like most good ideas, no series of VPs sat together and say, let's build a service bus at Microsoft. It was kind of like a skunk project that grew and took a life of its own. Like most good ideas, like .NET itself, by the way. Don't kid yourself, it was done any differently. So what was designed to address a connectivity issue, which I'm going to share with you, it turned out it's a great way of building applications as far as scalability, availability, security, extensibility. There's lots of good things here, and I expect this to be the predominant way of building any kind of application as time goes by. Also, don't kid yourself about the word Azure. This has nothing to do with Windows, Azure, and cloud computing. Everything will be running here on this laptop. This technology was called before that .NET Services, which is actually a good name, and before that it was called BizTalk Services. It had 0 to do with BizTalk, and it has next to 0 to do with Windows Azure. But Microsoft likes to lump things together, so don't kid yourself, okay? Shouldn't deter you that it says Windows Azure. So why do we need Service Bus? We need Service Bus because web services suck. In fact, web services suck royally, and they've been sucking to the point that for 10 years I've been saying on every podium on the planet, in every conference, don't use web services. Has anybody ever heard me saying those things? I've got witnesses. I was very consistent. Evidently, I was vindicated because now we have a Service Bus. How could I be so certain? Don't use web services. It's not because of the web. The web is a phenomenal mechanism for connecting clients to objects. It's because nobody ever does use the web raw. Instead, we erect all these barriers for communication. At the very least, you have a firewall in your operating system. Is that the only firewall you have? No, you may have some kind of a hardware firewall. Is this the only firewall? No, you may have something else. And what about addresses? The address of this laptop is 192.168.1.1. Does it mean anything? No. Who gave me this address, this router? What's the address of the router? The router is 1.2.3.4. Does it mean anything? No, because the bridge gave me this address. What's this address? Well, it's something got from the internet service provider. Does it mean this? No. And we keep adding stuff. And then we have load balancing, and then we have virtualization, and we have all these things. So pray tell, how would this poor client punch all these things and find a poor little object here? And the short answer, it can't. So instead, we do all these weird kludges. We put the object in a DMZ. Unless you're a security expert, you only have the MZ. You're kind of like missing the D portion of it. You have this gaping security, you're not even aware of it. And you could resort to static IPs, but do we really have enough IPs for every object on the planet? Because if you bind to the vision of web services, it's exactly where you need to be heading. And let's not talk about IP6. For the last 12 years, IP6 was always 3 years away. I'm beginning to lose my patience now. I don't think we're ever going to see IP6. And all these things are cumbersome, not real-time, and so on. As a result, it's not easy to do these things. Let's not even talk about security and all that stuff. So, a guy goes to the doctor and says, "Doc, it hurts when I do this." What does the doctor say? Don't do that. So if it's so hard to do this, I have a very simple advice: don't do this. And that's how I could tell web services is not a good idea in the raw, like this. Instead, you have to design around the problem. And the solution is you never connect the client to the services directly. Instead, you introduce a middleman. When you put this relay service in the cloud, that's the only relationship it has with the cloud. It's in the cloud because the cloud is neutral. It's neither good nor bad. You can establish trust against it. The pattern would look like this. You never connect the client to the service directly. The first thing that happens, the service calls out through its barriers of communication. It says, "Hello, I'm here. I'd like to receive calls." The relay service now authenticates the object. The client calls and says, "Let me authenticate myself against the relay service." Once that takes place, the client forwards a message to the relay service forwards it to the service. That's the pattern. How can you actually do these things? You can do these things because as the call heads to the relay service in step 1, it contains some trace elements of where it really originated from, and with some advanced network programming, you can actually deduce how to really punch all those barriers of communication and then go and hit the object. Now, this is the sort of pattern you've all been using for a long time. This is what, say, Skype is using. How could it possibly be you bring this little Skype applet on your tray and you can make a phone call to somebody else behind their home, Linksys router, and everything else? Well, they're doing something like this. They're doing something else, but kind of like that's what they do. So you've all been using this. Unfortunately, to implement this sort of thing on yourself is just an immense technological challenge. You have to know a lot of network programming to do it. In practical sense, the bar is set very high. Now, when Microsoft looked at this, they said, we're good at doing complicated things and commoditizing them. Let's take this whole thing and make it like a shrink wrap, kind of like Skype in a box, if you will. Here it is. And that's what the first manifestation of the service bus is. It's a relay service. Now, it's part of just one of the things it is. It has many other manifestations. But in its first incarnation, it was nothing more than just a relay service. It started that way. Now, it turns out that doing things this way has additional advantages. First of all, nobody ever sees your object. They only see the service bus, which means to mount an attack against your service, the first step is to circumvent the relay service. Not impossible, except the best security experts in the world designed this. Try and beat that. Try and do the no-service attack on the relay service. Try and do some kind of other sneaky attack. The bar is set very high now. This is not your knowledge of security. They have to circumvent it. It's the guys who did this. Totally different story. It turns out that because authentication of the client happens upstream from your service, there's no need to bother the service with managing security credentials and mapping username and passwords to identities and impersonating the clients and all that stuff you have to do today if you do it manually. You just let the relay service do it. And imagine, you just write your code without ever caring about security. It's a good way of doing things. You can also put some very sophisticated access control rules here. There's a whole world we don't have time to discuss called the access control service, which it's like a rule engine for authorization. If it's this but not that, and that but not this, allow it to go through. Else, don't allow it. And you can externalize all of this from your code. It's a good way of doing things. You can also inject here code to do pre-call processing and post-call processing, perhaps, and maybe have some distribution policies and extend your application this way. It's a very powerful way of building applications. And that's kind of like, in a nutshell, what the service bus is in its first incarnation. Now, to talk to a service behind the service bus, you have to have a base address, which includes the address of the service bus plus one of your accounts. Typically, it's called a namespace. Then a number of optional URIs. Now, once your service is running in a service bus, there can be an Atom feed showing you the list of running services. Now, Atom is a bit of a flaky mechanism. It's not real time. It's not very reliable. I suspect the only reason that they're using Atom is because this technology was mostly developed by Clemens Vasters, who is an avid blogger, and he knew how to use Atom. It doesn't mean that Atom is a good idea. You should have a full-fledged registry, full-fledged discovery. They don't have that. Okay, but that's what they have out of the box. You can actually control publishing to the registry using this enum, and it's an endpoint behavior you simply attach to every endpoint of your services that need to run against the service bus. And so the code might look like this. You instantiate endpoint behavior. You say, I'd like to go and publish to the Atom feed. You instantiate the host, and then you manually go over every endpoint, and you add the behavior, then you open the host. And you have to do it every time before you launch a service if you want it to be published in the Atom feed. Yeah, right. So let's fix it. So the first thing I did, I wrote a little host called discoverable service host, which derives from service host. It's used just like a regular host. It derives from service host. You can't tell it's any different. Except this one will automatically publish for you. It will basically encapsulate that act of smearing the behavior across all your endpoints. And that's kind of like my first baby technique here. Now note that this service host supports an interface called iService Bus Properties. It's my interface, which contains the credential used against the service bus, plus the addresses you monitor. In fact, I've written a massive set of helper classes and framework on top of the service bus, and all my helper classes support iService Bus Properties. I find that if you write a framework that needs to work with a service bus, it's incredibly useful to be able to go and reach down, and without knowing what it is, you're dealing with a proxy, a service host, some other thing. What's your credential, what's your addresses? For extensibility and specialization, it's great. So you can probably use that interface for your own design need if you need to. Now, viewing something like this for an Atom feed, but opening a browser and looking at the feed like this is a bit clumsy. So I wrote a tool. I call it the Service Bus Explorer. Service Bus Explorer lets you log in against your service bus. It parses the Atom feed and presents for you a logical view and a tree of your assets on the service bus. So as it stands right now, it only does services and buffers. It used to do other things like routers and queues, but those were taken out of the product before it was released. And they intend to actually put it back, so there's going to be more stuff in here. And so you can definitely use that instead of the browser page and hit refresh or whatever. I mean, it's not. It's not. When you're programming against a service bus, you use WCF as the predominant programming model. If you know WCF, life is good. You already know how to program against a service bus. There's a bunch of bindings. The three main bindings are the TCP relay binding, the one relay binding, and an event relay binding. The TCP relay binding is really the binding of choice. That's the workhorse. That's what you're going to use in the vast majority of cases. And if you need to use something else, I'm beginning to question the very point of even using the service bus. It's not canonical. And it gives you the best performance, the best throughput, minimizes the overhead. You can configure message size. You can do whatever you like. Now, it's just like regular WCF. You can have multiple clients sending messages to a single service. It will maintain a transport session through the relay service. For transport, you have to say SB. SB for service bus. Does it mean it's TCP? Maybe. It could also be HTTP. The binding is smart enough to see if the TCP ports are open or blocked, and if they're blocked, we actually fall back to HTTP. So they don't want to commit, they say SB, service bus. The downside of this binding, in theory, is it's not interoperable. It assumes the other party is also WCF over the TCP relay binding. The way I'm thinking it, that's always going to be the case. I mean, we're having so much trouble getting even a simple endpoint to go over other platforms. So the service bus, in practical sense, it's always going to be the TCP relay binding. That's real life. Let's do a little bit of a demo here. I have a simple service. The service has a counter. I also have here a form. The form is a label. And there's a counter property on the form that bumps the value of the label. Since what the service is doing is grabbing the form and then feeding into it the value of the counter, every time there's a call, we should see it reflecting the value of this counter. Now, in the world of normal web services, every object is per call. And so if we were to run it as a Max web service, we would see 1, 1, 1, 1. But one of the nice things that the service bus lets you do is pretend as if C# itself is stretched over the cloud. You're actually going to get the same object every time. So we'd see 1, 2, 3, which is a novelty. You can't do this in regular web services. Now, I'm not saying you always need to do it, but per call should only be reused, should only be selected if you need high scalability. If you don't need high scalability, this is a superior programming model. People like to program this way. And so, roughly speaking, this is what I have to do. Configure the endpoint. The client is just going to create a proxy, click the button, and use it. So here's the using code. So fairly straightforward. Almost like regular WCF, except I've got the SB here, I got the word relay here, I got this service bus thing here. Now, note, I'm deliberately doing in a virtual PC running XP. This works fine in XP. In fact, it works fine in .NET 3.5 as well. This has nothing to do with .NET 4.0 or the new generation of platforms. And as far as I know, I don't think they actually say that they support XP explicitly, but if you push into a corner and say admit it, they would say yes. So let me log on explicitly to the service bus. Now, this kind of acting logging I did is something that you're unlikely to do in a real application. You have to have this long token, like 47 characters of goo, that you have to pass along. No user can ever type it, and you don't want it to be in a tag it on a monitor or anything. This is really begged to be integrated with something else. The classic integration mechanism here is you take your Active Directory, and you federate it to the Active Control Service so that the user logged in the morning to the Windows box, they actually log in implicitly against the service bus. Next time they make a call, they just go along. That's kind of like a better way of doing it. So let's make a call. A bit of a delay as the client is doing its handshake. Now it's coming. So, like I told you, it's as if C# itself is stretched over the cloud. Because my programming model was new and then .equal. I mean, that's my programming model. Now, if you just try and visualize what is going on here, this is running inside a virtual PC. Here it is. And whenever I hit this button, the client has to go outside the virtual PC, hit the virtual PC firewall, and then has to somehow go outside. I'm actually configuring it. If I were to look at the settings here, I have it now configured as network under translation, which means it's kind of like in its own virtualized network segment with the virtual PC acting as a bridge of sort. So it first has to kind of like swim in this virtual network, punch the adjunct translation, then inside the physical laptop. The physical laptop is now connected to the internet using my cell phone. So it has to actually then swim inside the physical laptop, go into the cell phone, go and swim to the internet provider that gives the cell phone connectivity, go to the service bus, turn around, back to Atlanta, find this laptop, punch its firewall, find the network card, go to the virtual PC, find the under translation, swim inside that virtual network, find the XP machine, punch its firewall, find the object, bump the label. And all of that takes place every time I click this button. You know, this is good enough even for highly interactive applications. It's great. And note, I'm doing it inside the virtual PC. I'm doing it in debug mode. This is still good enough for most applications. Is this what you need to do? The other binding is called the one-way relay binding. It doesn't have a direct use as is. The only reason I'm showing you that is because it's a stepping stone for something else. But you have to understand the stepping stone to see something else. This one is meant kind of like in a one-way find forget message, but it's not really one-way find forget. What it means is no reply message coming out of the service to the client. So the client is going to push a message to the relay service and return. The relay service is going to deposit it in a buffer, and then from the buffer it's going to go to the service behind the scenes. Now, it's not exactly find forget because there's some other limitation here. The service has to be running to receive it and such, but by and large, that's what it does. The message size is limited here because if they buffer stuff, they have to cap the message size. Otherwise, they open themselves for some kind of a buffer overflow attack where someone's going to send them the entire Encyclopedia Britannica in every message, and then they're going to overflow the buffer, so they cap the message size. The real use for the event relay binding is a specialization of it, which is the event relay binding. The event relay binding is just like the one-way relay binding, except it allows any number of services to monitor the same address in a service bus. Normally, the TCP relay binding and the event relay binding are just like regular WCF. Addresses have to be unique. So in WCF, if you open a port or a pipe, only that service can monitor that. Addresses have to be unique. Just like in C#, it's a really, really bad thing if two objects share the same memory address. That's not a good sign, right? So, except the event relay binding. The event relay binding allows multiple services to monitor the same address. Since you can have any number of clients posting messages, what you have here is a general purpose end-to-end communication mechanism. Now, if you have the event relay binding, you stop viewing the service bus as a relay service, you start viewing it as an event hub. That's the second manifestation of the service bus. It's just an event hub. And let's do a little demo here. I have a client here that's going to control the color of a traffic light. You can see my ability of user interface leaves somewhat to be desired. And here's a traffic light. And I'm saying, look, I'd like to use the event relay binding. I'm monitoring the traffic light URI here. And in fact, let's launch a few of them. Make it yellow. No. OK. And let's do it in a timer, and just while it's doing that, let's keep talking. Now, sure, you can do it yourself. So what's the big deal? It's an event hub. I can write an event hub myself. Up to a point, yes. It turns out that there is no good answer in conventional programming for handling a very large number of subscribers. You see, suppose you have 3 subscribers. So you can do it in a for each. You just give it to every one of them. What if you have 300? What if you have 3, but the first one takes forever to process the event? If you're blocked when the first event takes place, you're never going to be around for the second or third. Even if it doesn't take long to process the event, if you simply have a long enough list, by the time you finish scanning it, too much time has elapsed. You may exceed your original publishing timeout, or maybe just getting the event too late is just as bad as not getting it at all. So you say, sure, I know how to deal with that. I'll do it concurrently. I'm saying, fine. If you have 3 subscribers, spin 3 threads. What if you have 10,000? Are you going to spin 10,000 threads? The answer is no. So you know what? Let's use a thread pool. Fine, let's do a thread pool. But the pool is capped at 20 threads, 50 threads. There's a number there. And any number of threads in the pool, I'll give you a scenario where I have too many subscribers. In fact, there is nothing in conventional programming at your disposal that handles 3 million subscribers or 300,000. It doesn't matter. There is a cap, a natural cap, which is probably around a few hundreds, by the way, if you try and put a number on it, as to what is feasible in conventional programming. And any attempt to lump more subscribers, we see a degradation in service. In conventional programming, scalability times throughput is basically a constant per machine. That's the reality. The service bus doesn't do a for each, and it doesn't abide by the maxim that scalability times throughput is a constant. In fact, 3 subscribers, and in theory, 300 million, should get the same level of service, an order of 1. What I suspect they do, they don't tell me, but I suspect they do it, they take the message, they clone it internally, they broadcast it internally into all the listeners. So in fact, 3 subscribers and 3,000 present the same overhead on them. And they're completely decoupled, by the way. Let me blow up this one. It's like, nobody knows, nobody cares. It keeps going. It's a very loosely coupled way of building applications. So as an aside, the availability of technology that lets you handle very large number of subscribers opens this theoretical possibility for very interesting things. There's whole business models that require very large number of subscribers that we simply can't do today. Think about micro-financial transactions on a planetary scale. Think about energy management and so on. There's lots of scenarios that would need this. Now we have the technology for doing it. OK. So far, if you were using the service bus, you already knew everything I said. Let's drill a little bit further. Is it an event hub? Yes. Is it a pub subsystem? Not really. Why? First of all, in a real-life pub subsystem, I'd like to have some kind of an admin support. I'd like to go, and even post-deployment, have some kind of a tool and say, subscribe to this, don't subscribe to that, or you paid extra, I'm giving you this event. There's no way of doing it here. Second, there's no per event or what is known as topic subscriptions. If you have an event contract with event 1, 2, and 3, and you open an endpoint for event 1, 2, and 3, you're going to get all 3 events. Suppose you care about just event 1, doesn't matter, you're going to get 2 and 3 as well. And if you discard it internally, which of course increases the load on your system and requires you to program against it. And so imagine this is my event contract. I've got event 1, 2, and 3. If you were to just open a host, you get all of them. So a naive solution here would be, let's start mapping endpoints to events. So that I would logically have 3 endpoints here. And when event 1 happens, the publisher would know to go to that endpoint. And then I would launch a host that monitors just that endpoint. And I would have another host for event 2, another host for event 3. That would actually solve it. Except this is a very tedious and repetitive code that requires a lot of programming. And it's also expensive. Today, the service bus charges its customers per connection. So if you have 3 hosts, you pay for 3 connections. So you pay as many as events. It doesn't make any sense. So I streamlined it and enabled you to support what I call discrete events using my service bus events host. It derives from the discoverable service host I showed you before. It's used very much like a regular host, except the constructors must accept a base address. You will see in a second why. It has logical subscribe and unsubscribe methods. Now, if you just call subscribe, it will use reflection to find all the contract of the service type, and will subscribe to all events on all contracts. You can give it just a particular contract, so it would subscribe to just events on that contract, or even a particular event on a particular contract. Unsubscribe is the other way around. So you can subscribe to all of them and just unsubscribe event 3 if you want, and so on. Any kind of composition goes around here. Now, it will default for using a secured version of the event relay binding, but if you want to do something else, have a helper message, you set binding, you can give it whatever you like. It doesn't need a config file, although you can give it the binding man to look the config file, to look it up from the config file. It all it really needs is a base address. In fact, it requires a base address. In the world of regular WCF, base address is optional. Here it's mandatory. Why? Because it would actually pretend that you have this layout. It will pretend that you have these 3 endpoints, while you still pay for just 1 host. But you can see all these endpoints have the same base address. So here's a potential use for it. I've got some kind of a subscriber service. Here's the base address. I give it the type of subscriber and the base address. I do open, I do subscribe, unsubscribe, subscribe, unsubscribe, and so on. These methods can easily be tooled, by the way. I don't know what your end admin tool would look like, but here's a nice hook that you would have maybe a drop-down list, a radio button, and you would say subscribe and subscribe. It would actually go and call subscribe and subscribe on the underlying host. While the host is running, mind you, there doesn't need to be open the host, close the host, and so on. That's another disadvantage of what I showed you before with mapping as many endpoints as events. You would have to literally go and open a closed host. No, this is while the host is running, which is better. It stores the subscription in a dictionary that maps the subscriber operation per contract, which lets you just modify the dictionary in memory. That's all it does. How does it actually work? There's a little known fact about the service bus, which is the moment you launch a listening service against a service bus, it takes the address and monitors not just that address, but any sub-URI of that address. Okay? So I'm going to be leveraging that particular hook. What I'm going to do is I'm going to launch a single host that monitors just the base address. Now, if clients are going to send messages to any sub-URI matching a particular event, I will still get all these events. I would still have now to sort it. And I will do the sorting using interception. And so it would actually add endpoint per base address per contract. If you give it a base address, it will append to it the contract name. And that would be what it would actually monitor. But it would pretend to the clients as if it has this layout. So the client would actually shoot messages at what they think are 3 different endpoints. But in fact, it's just 1, because they're monitoring just the base address here. And that would mean there has to be a step in between the service bus and the actual service where somebody is examining the message and routes it and says, oh, it goes to event 1, it goes to event 2. There is a dedicated hook for it in WCF called dispatch operation selector, which lets you select at runtime which operation the method is destined to. So every method in WCF contains the name of the operation its sender intended to. But you can intercept it and say, no, 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 you go over there. At your own risk, mind you. Who said the signature matches or whatever? Nobody. But you can actually do it. Note you actually ref the message here. If you actually null it, the message will be dumped and not processed further. Now, the service bus events host, when you construct the host, is going to do some initialization of this dictionary of subscriptions, instantiate an event selector, and give it to all endpoints of the service. Now remember, the endpoint of the service, it's going to add as many endpoints here as what you have in the contract and such. The hook itself is done using a nested private class. Nobody needs to see it. I call it the event selector. The event selector supports two WCF hooks, the operation selector and the endpoint behavior. The endpoint behavior is where you attach your selector. So the way that works is the endpoint behavior is applied dispatch behavior. We are giving the particular dispatch. And then you get the dispatcher for that endpoint, and you force into it an operation selector, basically yourself. Now the implementation of select operation processes the message, extracts the operation it was supposed to go into, and then it sees if there's a matching subscription for it in a dictionary. If it is, it allows it to go through. And actually, it forces the operation it would actually go through. And that's where the selection takes place. Now, if you didn't subscribe to it, it dumps it and says never happened. So you pay for one connection, but you get the illusion of multiple hosts. For the publisher side, you can actually use a regular one-way binding with a regular proxy. The event relay binding has no meaning for the client whatsoever, for the publisher. So you can actually still use just the one-way relay binding. But now you need to start be careful about the matching, because you need to actually say, well, it's /contract/event. So I have a dedicated proxy that does that. I call the service bus events client base. Used just like a regular proxy, except there's no need for any config file. All it needs is really the base address. And here's a definition of it. It derives from client base. There's more stuff it does here, like security. Let's not get into that. Its constructor takes the base address. And you would use it like this. You would create a proxy of yours deriving from that, just like a regular client base. And you would say channel dot. That's all you say, channel dot. And it would actually do this appending for you. And you give it a base address, would append to it the /contract/event and send it properly. Now, the /contract is done here at the constructor. The /event is done by the channel dot. So internally, this is actually what all proxies do in WCF. So I'm going to simply be leveraging that. And do I have it here running already? No. OK, here's my subscriber. Look how succinct and terse this code is. You have a pure subscriber. This subscriber only processes events. There's zero code here that wires it up to anything in your system. It's a pure event processing sync. That's all it does. I also have in program.cs, I have my, I have a form here. And the form has this host. And I'm going to instantiate it. Then I can select here which event I want to subscribe to. When I click subscribe, it's a simple tool. It would look at what is selected in the user interface and would call the appropriate subscribe method. That's my tooling demo. The publisher has some user interface. We can select which event to fire. You click the button. Depending on what is selected, you fire the appropriate event. It looks like a regular proxy. This is exactly what it is. So let's see it in action. Let's subscribe to all events and fire event 1. Good. Let's fire event 2. Excellent. Let's unsubscribe from event 2, just event 2. Fire event 1. Beautiful. Fire event 2. Nothing, 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 nothing. You see, discrete events. But it requires this knowing that, yes, it monitors everything underneath and the hooks and everything else, but it's all packaged in these helper classes. It's all good. talk about discovery. The atom feed is not discovery, just an atom feed. Discovery is very useful. In fact, half an hour after this session, I have a session on discovery. But discovery was designed for the intranet, and it uses UDP. Blasting the entire internet with UDP packets would make you very unpopular very quickly. And so it's not a good idea to do it. On the other hand, that's just a technical limitation. Discovery is a very useful technique. What it lets you do, it lets you have a very loosely coupled client and service as far as deployment. I don't need to bake into the client code the address or put in a config file. I just move the bits to the target machine, and I pull the code on the machine, and things figure each other out. That sounds like a good idea. In fact, if I know the client is going to use discovery, why insist on any particular address? You see, when you're launching a service against a service bus, who says /service is available? I don't know. Maybe somebody else has already occupied /my service. It's exactly the same problem in regular TCP. If you use TCP programming in WCF, you open port 8000. OK, who says it's available on the client machine? Nobody. Welcome to the guessing game of WCF. Well, if you guess correctly, your application gets to work. But if you know the client is going to use discovery, why not use any address? Maybe a GUID. Doesn't matter. I mean, if you create a GUID right now, I assure you nobody's using that GUID. Why not use that? Now, in addition, I'm going on a side here on a tangent. .NET, right, WCF is using config file. Config files are a hack. How many of you agree that config files are a hack? Right. And it's not really WCF fault because .NET never shipped with a good config story. In .NET 1.0, we should have a centralized metadata and configuration story. I don't know if it's going to be database or in the cloud or whatever, but we should have had something better than the cheesy config files. OK? Now, the reason it's cheesy is not because it's just not type safe and easy, you can get by with these things. It's unmanageable. I mean, if you have 5,000 client machines to update, are you going to go and chase 5,000 config files? Even 50 is too much. There's really no good support in .NET for very large number of client machines banging on other client machines and such. No good story there. But you know, if you start opening your stuff to web services in the cloud, 5,000 client machines on 3,000 customer deployment sites, I mean, let's make it more interesting. Are you going to go and figure the config files? And so you need to discover these things at one time. Now, the service bus may support discovery in the future. They're not saying yes, they're not saying no. It may support it. But it sure would be nice to combine the two benefits. The benefits of a very loosely coupled deployment where just move the bits to the target machine and things work, with this unbelievable unhindered connectivity of the service bus. Now, you can't do UDP. But what you can do, you can substitute UDP with the event relay binding I showed you. Instead of looking at it as an event binding, its proper name should have been the broadcast binding. If I choose the broadcast event on it, it's an event binding. But if it's something else, and you can actually do just that. In fact, what I chose to do is to mimic the entire WCF discovery behavior. For better or worse, that's the behavior we have. Now, if they're going to support it in the future, I suspect there's going to be some parity in the way it looks like. So I took all the WCF classes and helper classes that they have for discovery and implemented all of them on the service bus, substituting event binding for UDP. OK? That's what I did. Now, I'd love to even use the interfaces they use internally, except they made all of them internal. The long thread with the PM behind it, I don't know why they made it internal. He claimed it doesn't matter, but it does. So we can't consume an internal interface. So I defined my own interfaces. So I defined an interface I call iService Bus Discovery. You never need to use these things directly. I'm just showing you how the framework I wrote actually works. And it enables you to expose an event binding on a service bus to receive discovery requests. Every service that needs to be discovered would subscribe to that event endpoint. This is no different than a discovery mechanism in regular WCF where the service exposes a UDP endpoint to be discovered. The client is going to expose some kind of a service bus discovery callback. We'll receive the response from the client about the address. And once you have the address, you proceed to invoke it normally. So the pattern would look like this. We got the client, we got the service. The client has no idea what the service is, but the service is monitoring this event's endpoint. the client is going to first blast through the event endpoint to all monitoring services. There could be many services here, monitoring the discovery request, and say, I'm looking for a service supporting some contract. So services that support some contract are going to respond back to the client and say, here's my address. Now the client is going to have to go and invoke whichever it wants. This is just like regular WCF discovery. Now, at this point, there's a lot of work to be done. You have to launch a service that would monitor this guy. And you have to have code that would respond here. And you have to do all of this, of course, asynchronously and concurrently, and then make it so that it doesn't affect the service. So I baked all of that into the discoverable service host I showed you before. This is why it's not called the feed service host. It's called the discoverable service host because it does Clement's Atom feed, and it does the discovery. Now, to enable it, you have to add a discovery endpoint and a discovery behavior just like regular WCF. Now, I'm not using that behavior at all. I'm not using the discovery endpoint of WCF, but this is a forward-looking decision. If they are going to support it at some point, I suspect they're going to do this as well. Another advantage is the compatible deployment model. In fact, the same host can be now discovered over the intranet and the internet because it's the same config for both. In fact, you don't actually have to do any of this configuration. The discoverable service host will do these things for you programmatically. But the pattern I showed you doesn't have to work with my helper class. You can just implement it yourself. And so all you do is you construct the host. There's additional hooks here. What is the address of the event binding? Well, it defaults for discovery request URI, but you can force here a different URI. You can even force here a different binding, both for receiving the request and responding. Now, the discoverable service host would have an internal service class called the discovery request service, whose mission in life is implement the service bus discovery contract to monitor the incoming broadcast of the request for discovery. And it will basically do that. Then it would also call back for implementation of this discovery request. Implementation would simply go and call back to the client and give it the address. The use of it looks like this. Instantiate a host. As far as you're concerned, it's a regular service host. There's nothing special about it. The programming model is 100% on parity with regular WCF. You instantiate a service host, but you instantiate it with a discoverable service host. You give it some kind of a base address in a service bus. And now you can even do this. Let me add an endpoint whose address is a dynamic GUID URI. Once you do this, there is no way anybody can consume this service without discovery. There's also no way anybody can conflict with you. For the client, in normal WCF, there's a class called discovery client, which acts as a proxy against the WCF discovery endpoint. So I wrote the service bus discovery client, which looks and smells just like it, except the find method here does the finding against the service bus. And if you think about it, it's more than a proxy. It has to, at once, send the discovery request to the service bus, and also host another service to receive the discovery response. So the helper class does all of that. It defaults to the same URI address as on the other side, but you can provide a different one. You can override everything here. And so here's the programming model. Now, those of you familiar with WCF discovery, the only different line here is I'm instantiating a service bus discovery client, not a WCF discovery client. But the entire sequence here is regular WCF discovery. So if you're in WCF discovery, we can move on. If you don't, let me break it down for you. There's a criteria, you say what you're looking for. I'm looking for the type of my contract. You go to the service bus, you find it. Then you close the proxy. You may find multiple, and so you go and select which one you like. You get the binding, and then you go use a channel factor to create a channel, and you go and consume it. Now, I'm not saying this is a nice programming model. I don't think this is a nice programming model. I'm just saying this is the one WCF provides for us, so I'm doing the same. Now, if you think about it, every time you're going to create a proxy, you're going to do this. This is a lot of work. In addition, discovery takes time. In normal WCF, it takes 20 seconds by default. With a service bus, who knows? So I actually impose the same timeout and everything else. But if you're only looking for one service, why wait 20 seconds? Why wait at all? As soon as you find the first, return. That's one optimization. The other one is all this kung fu with the addresses and such. So I have a helper class called the service bus discovery helper that has basically two methods, discover address and discover addresses. If you're looking for just one address, you know there's just one service somewhere, You call this, it immediately returns with the address. As soon as it found the first, it returns. We can also say discover address says. It will return an array of all the addresses it found. OK. Let's see what we have here. I have a service host instantiated as a discoverable service host. I'm going to programmatically add 2 endpoints here whose address is a GUID. Now note, the first address is a TCP relay binding. The second address is going to be for a MEX endpoint. I mean, even MEX can be dynamic in this scenario. And then I'm going to just open it. The client, when I click this button, is going to use the helper class to go and discover the address and explicitly create a proxy. Now you still have to hard code the binding. There's an interesting way around that. An interesting trick is, instead of discovering the service address, go and discover its MEX endpoint. You get the MEX, you can process the MEX, and extract from the MEX the address and the binding, and then construct the proxy. And that is exactly what this one is doing. So I have a discovery factory that goes and creates a channel. All you have to do is tell it, look, I'm looking for this type of a contract against a service bus. Boom, returns a proxy. If you definitely do multiple trips, if we do one discovery trip against the MEX endpoint, find the MEX address, do a MEX query against it on the service bus, get the MEX, parse the content, then create a proxy. OK? So let's run these things. And I may have to run this demo as admin. I think this is demo I have to run as admin. We'll see in a second. OK? And while it's doing that, let's bring up the Service Bus Explorer. Let's explore the iDesign namespace, my namespace on the service bus. Don't get too attached to the progress bar. I'm just cycling it. I learned from the best. At least I'm not saying it's going to take 23 days. And we see a number of endpoints here. First of all, this is the service endpoint. It's a horrible little GUID behind my service. Nobody can ever consume it without discovery. Here's also my pure dynamic MEX endpoint. Here's, by the way, the event endpoint for the discovery. Put that aside in a second, and let's look at the client here. Let's go and invoke it. We may actually get to see that endpoint as it's being created for the client to call back, but we'll see in a second.
Some of the business functionality that you want to bring out?
Discovery. Discovery. Discovery is not a business scenario. Yeah, so I should run it as admin. I'm sorry. It's discovery. It's like saying, what's the business scenario for a class factory? Well, I don't know. It's a class factory.
So discovery for events, for new scheduling information?
Discovery is independent. The question, what is this discovery good for? It's like asking, what's a class factory good for? It's a general purpose programming technique that lets me avoid hard coding in the client config file when it's code the address, and I'll figure it up on the fly. And literally, in my opinion, this is how you should actually work against a service bus. I mean, assuming it works. This is far better than hard coding those addresses and hope for the best. Yeah? So. And I mentioned my discovery helper class. OK. Much the same way you can support announcements. The discovery mechanism I showed you so far, and discovery in general, assumes a fairly static service. Now, once a service is deployed, that's always its address. Clients come and go, and they discover it. Sure, that's good, but what if services come and go? And every time they come and go, they're doing a different address. And then that model is not a good one. You better turn the table around here and run the client as the passive one and make the service be the active one. It would be better if the service would be to announce to the client it's coming and going. That's, again, a general-purpose WCF facility called announcements. There's a base support for it. And you can do the same as substituting UDP for the event relay binding, so that the client, when the service announces, it will do it over the event relay binding. So the pattern would look like this. All clients that wants to be announced subscribe to some kind of an event announcement endpoint. Services, as they come and go, blast here the hello and bye events of discovery, of announcements. The client gets their address, and they go and invoke it. That's the idea. And guess what? The discoverable service host I showed you before also supports announcements. You do nothing. You just say host.open, and here's what you get. You get the Atom feed, you get to be discoverable, and you get to announce to all your clients. So there's additional hooks here. Where do you announce? It will default to availability announcements URI, but you can force a different URI here and a different binding. So there's lots of flexibility here in the model. And we do the automatic announcements for you, and we'll fire all of them, of course, asynchronously. For the client, in regular WCF, there's a built-in mechanism for receiving those events. It requires it to host a service and do a lot of low-level kung fu, which I had to fix for WCF. So here's the same fix for the service bus. I didn't bother here to mimic completely the WCF mechanism, because that one I thought was just too ugly to use. So let's not mimic something ugly. Let's do something good. Here's something good. I call the service bus announcement sync. And there's two ways of using it. It's actually derived from a general purpose address container that lets you contain all the addresses that were announced, or use an event model. So you can subscribe to events or go and just process the container. Programming model may look like this. You instantiate the announcement sync. You have some kind of address container. Services come and go, come and go. You have a way of knowing which address in the container you want to invoke. You're going to plug the address. You're good to go. And let's run that. Oh, well. Let's try and do it in admin, as admin this time to make the demo actually work. Ugh. May actually be here. Yep. Okay, the first thing I'm going to do, I'm going to launch the client, because the client has to be up to receive the announcements. Let's look at the service. Here's my service. I'm just going to throw a message box out. Let's look at the hosting code. I'm going to instantiate a discoverable host. And again, I'm going to use a GUID for its address. So the client is up. Let's launch the service. And note what the client is going to do when I click this button. Client is going to go to the address container, pluck out of it the address, and create a child factory and use it. So as soon as the service is up, we can actually go and use it. So it's up. Let's go and use it. See? And this was done totally dynamically. I mean, the GUIDs and everything else. Poof, service is up. You fire the event. OK. Now, over the years, I've published a tool I call the Mex Explorer, which is kind of like a reflector for WCF. You give it a service endpoint, a Mex endpoint. It takes the Mex, it goes to that endpoint, sucks in the Mex, processes it, and visualizes it in a nice tool in a tree. You can drill through the endpoint and such. So I took that tool, which I've had since 2006, and I superimposed service bus support on top of it. So there's a service bus entry here. You can log into the service bus. You can click Discovery. You can give it the parameters of what your discovery mechanism would look like. What is your discovery path? If you want to support availability events, and if so, where. OK? And now, when you click Discover, it will actually do active discovery against the services in the service bus, find the MAC address, suck the MAC, and reflect it for you. And again, let's do that as admin. OK, so let's just run the Max Explorer first. And I'm going to go to the service bus. I'd like to log into the service bus, give it my namespace. And let's go to discovery. And let's say I'm going to monitor discovery request here. And I also want to support announcements. I'm done. Let's go here. And it will take it a while, because now it launches all the services that monitor the endpoints and so on. So it will take it a little bit of a while before it comes back up. OK, it's up. Let's launch a host. And this host is going to be using my discoverable service host, which also does discovery and announcements and so on. And note, I'm not going to hit the discover button, because the Max Explorer would also support announcements. So in theory, as soon as the services are available across the service bus, it will receive the announcements, turn around, query the Max, and visualize the whole thing. That's this. Oh, here's the announcements. So if everything would work well, what we're going to have here is your ultimate application explorer. You can explore for you all your assets when you hit explore or discover. And it auto-refreshes. As things come and go, it shows you what's going on. A little bit better than the Atom feed. A little bit better. Unless you want to sit there and do F5, 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 F5. I mean, it's up to you. OK? So here's the second notification coming in. And in the interest of time, I'm not going to hit discover, but I can also do an explicit discovery query against the service bus. And of course, if I go here and I shut down things to receive those announcements, and poof, everything is refreshed, going away. OK? Let's talk about buffers. The service bus has a lukewarm, wishy-washy, kind of like queues, not exactly, concept called buffers. And there used to be queues in the service bus up until the release, and they pulled it out. And queues are definitely on their way in. In fact, when I talked with the team on what to do for TechEd, they said, OK, you cover the here and now, what you can do with it. We'll do all the future stuff. And I think there's sessions here about the future stuff and the queues and the routers and such. It's all coming. Alone, just using buffers is not really that exciting. I mean, yes, you can buffer some of the calls, but it's kind of like the only way of me showing you using production code what the queues will actually look like, which is the main reason I chose to show you this. And so instead of having a junction in the service bus with just a URI, which you can use it as a relay or as an event hub, now you can say, you know what, let me start viewing that junction as a buffer, or in the future as a queue. So now you stop viewing the service bus as a relay service or an event hub or discovery mechanism. Now you view it as simply a storage, a queued storage, store and forward mechanism. And by and large, you cannot do queued calls over the internet. You know, HTTP, connected, that's it. TCP, connected, that's it. But here you could. Now, be aware buffers are not the same as queues, are not durable. You can't store messages for a long period of time. They definitely limit how many messages and their size. And there's a number of reasons, not the very least of it. If they were to allow you to do these things, they would have to start charging you for storage, not for connections. And so they didn't want to do these things. So today, it's kind of like between queued calls, maybe find, forget calls. It's somewhere in between. But queues are definitely coming up. What can you do with it today? It's probably a little bit better mechanism for synchronous calls and regular synchronous calls. If you have a chunky call to do. If you have an application which is usually connected but not always, then you have to assume it's never connected, which means always do buffering. Right? So for that scenario, it's good. It allows to have some elasticity in the internet wire. You can pull it, you can bend it. It's not the rigid connection you had before. Kind of like. Now, all the messages are just one way. You basically create a raw double-shift message and you post it to the buffer. There's no more of getting results or errors or callbacks or anything. So my Service Bus Explorer lets you create these buffers. You can go and create a new buffer. You can establish some policies, some properties on it. Once the buffer is there, you can actually go and modify some of these things. I'm even allowing a novelty called purge all. and I can purge a buffer. And the way it does is there's C# APIs against the service bus that lets you create the buffer and modify it and such. So all you're doing really, instead of writing C#, you're using the tool. Now the main reason I put these things in the first place is because I was sick and tired of just writing C# every time I wanted to actually change something. That's exactly what tools are supposed to do. So that's what the service bus is now doing. There's no API for purge all. And the way I'm doing purge all is I go to an existing buffer, I copy all its properties of the policy, I delete it, and I create another buffer instead with the same name and the old properties. It's cheesy, I know, but that's because I didn't put the purge all methods in the API to begin with. I don't know why, but for us it's not to question, for us it's to work around things, right? Now, the big gotcha with the buffers and with the queues as well, the service bus requires you to work with raw WCF messages. Forget about structured programming, forget about my method, forget about parameters. You have to compose a raw WCF message and pass it on the other side, which is an incredibly cumbersome programming model, absolutely not object-oriented, it's not type-safe, and I kind of got used for those things over the last, 35 years? Yes. Yes, I know these things are messages under the covers, but I don't want to program that way. I mean, look at WCF. There's messages under the covers, but you have a C# programming model superimposed on it from the top. That's a better way of building applications. I get the benefit of messaging, which is arguably a superior programming model, a superior connectivity model, but I get C#, which is a superior programming model. Now, which means at some point in your application, you would have to do conversion between regular service calls and raw messages back and forth. And it can be done, it requires a lot of low level and goo. So I automated all of that with a helper class called the buffered service bus host. The buffered service bus host derives from service host. It's used just like a regular service host. You can't tell the difference. Only thing it requires is a base address, so it requires an address for the buffer. And once queues are available, I already have the class that does the same for queues. So it's absolutely valid, the technique I'm showing you here. And I really modeled it after the MSMQ binding, because if you think about the MSMQ binding in regular WCF, exchanges WCF messages under the covers, but pretend it's just regular C# calls to send one and to receive one. So I said that's actually a good programming model. Let me do it for the service bus. And that's what my buffered service bus host is doing. For the client, I wrote a dedicated proxy called the buffered service bus client that lets you program as if it's regular C#, but in fact, it would post a raw WCF message to that buffer. And let's see it in action, and we talk about maybe how it's done. So we can actually pretend you have a regular endpoint over the one-way relay binding, and it has a buffer and such. And what the client is going to do, the client is going to turn around and just call it. This is a true structured programming model. Now, in raw service bus programming, if the buffer is not there, bad things happen. But my proxy class will detect that the buffer is not there, silently create it, and then forward it the message. Same goes for the host. If you launch a host against the buffer and the buffer is not there, bad things happen. But my host will detect that, silently create the buffer for you, and monitor it. So let's launch the client. And let's launch the Service Bus Explorer. And let's wait for it to finish exploring. And we have nothing on the service bus. Let's call the service. Now note, I don't have a service, I don't have a buffer, I don't have anything. But I called the service. And it's still doing it. This is the stuff going on here. OK, it's back. Close it. Refresh. And guess what? There's now a buffer in a service bus with a little message inside. Let's launch just the service. And look at my hosting code. Service host new open. That's it. That's all I'm doing. Service is up. It will detect there's a message for it. Whoop, here's the message. There you go. Kind of like cute calls over the internet. Now you got elasticity in your internet wire. OK? You can see the possibilities here. Right? Now, how is that actually done? So the buffered service bus host is a really, really sophisticated thing. If you want to see some really interesting kung fu with WCF, take a look at what it's doing inside. What it's doing inside is it takes the service type you give it, and it hosts it internally over IPC, over named pipes, as a regular WCF service locally on that box. And one of the things WCF lets you do, its extensibility mechanism lets you build half an extensibility chain. Because normally there's two halves. There's from the proxy to the channel, and then from the channel to the service. And normally when you say new and such, you build the whole thing. But you can actually build just a half of it, just from the channel up to the object. So what it's doing, it uses the service bus APIs to go and monitor the buffer, detect there's a buffer there, suck it out using the service bus API. It's a raw WCF message. It constructs half an interception chain, feeds into it that message actually ends up over named pipes into the service. So the service gets a look and feel that a regular WCF call just happened. All the WCF attributes, it's all there, but I get this nice programming model on top. Okay? It's not unlike what the MSMQ binding is doing, which is why I model it this way. And for the client, I do basically the same thing. I give it the look and feel that it's a regular WCF call. I intercept it just before it hits the wire, take the message, post it over the service bus APIs to that buffer, and return to the client. Same idea. Now, when you're doing queued calls or buffered calls, those calls are fundamentally one way. There's never a way to get the results or the errors or anything, because it may not even be a service. Look, I'm posting to a buffer I shut down. The service is not even running. 2 days from now, it's going to wake up and then what? If the nature of the call is fundamentally one way, no biggie. What if it's not? What if the call does have results and errors and such? I need to know about it. Well, the result is that in MSMQ programming and in buffered programming and in queues programming on the service bus, they had to equate it, which is an imposition. What if it's not the same? The technique is you have to design around it. And the way you design it is the client is going to provide a dedicated response buffer where the service is going to call back to that buffer and deposit the response in. And the client is going to go and process the response at leisure when it needs to. At which point, this is a lot of work to do. And there's additional things to worry about. So here's what the pattern would look like. The client posts messages to a service bus buffer, which goes to the service at some point. The service has a response. It sends it back to a response buffer that some response service provided by the client processes. This is a general purpose response service pattern. This has nothing to do with the service bus. That's how you handle results of a queued call. Okay? Now, that's the 30,000 feet overview. It turns out this is a can of worms. For example, how would the service know where this buffer is? I mean, in theory, we know where this is. We just put it in the config file of the client or whatever. But what if I have multiple clients, each calling to the service, each with a different buffer? How are you going to figure these things out? And so the observation is that the client is going to have to include in the message also the address of the response, because every client may have a different response. In addition, because of the highly asynchronous concurrent nature of these calls, call could actually reach the service in whichever order, and of course complete whichever order, and get the response in whichever order. And so the client may actually use the calls bam, 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 and they may complete bim, bim, boom, and reach the service response in whichever, right? Even worse, what if the client takes the same response service and give it to multiple services, and even if you use the call ABC, it could get executed BCA, and the response comes back in whichever order. Now what? How would the pull response service make sense of it? The observation is there has to be a unique way for you to identify the calls. And the service can't be dealing with it. The service doesn't know what is unique enough for the response service. Is I++ good enough? I don't know. Maybe a GUID. Maybe an email. You don't know anything. So you also have to include some unique ID in every message you send from the client to the service. There's just a lot of things to do here. So I did all of that. And I have a little framework that does everything I just showed you, creating the buffers on the fly. The buffers don't have to be there. You just say new, bloop, the buffer gets created. It packages the unique IDs and the addresses in message headers, passes them along to the service. And basically, I took the framework I showed you before, which lets me have a structured programming model over the buffers, and I further specialized it to deal with this case. So I'm leveraging everything I showed you before, plus this.
You have a persistence model similar that MSMQ binding would have, right? If the service were to be restarted or the bus would be.
The question was, is a persistence model? The buffers are not long-lived, so it's a moot point. But if there are queues, then the answer, you don't need one. Your queues become your persistence model, right? Yep.
The queues went live today.
And the queues went live today, says Ron. So everything I showed you so far works on the queues as well. OK? Thank you, Ron. OK, let's see what we have here. We have a calculator service, and the calculator is going to allow us to add two numbers. Adding two numbers on a one-way call is not a good idea because I'll never get the result this way. OK, but I still want to get the result. That's a business logic I have to execute. And here's the client. The client has here a text box. I can actually generate the request here. And let me just shift here something. And what I'm going to do is I'm going to read from the user interface the numbers. I'm going to ask my proxy to my buffered, soon-to-be queued service to add those things for me. Now, where's the response service? I actually made the form be its own response service. So what I do is the form supports the calculator response contract. If you look at what this does, this simply says, well, the add was completed. Here's the results. Here's some exception information if you have any. And so if we were to look at the code, the response is going to come in here. Now, the response is going to come completely asynchronously, who knows when, where, and what. So I'm going to store it in a dictionary. So I have a dictionary here that has the method ID and the result. And fundamentally, all this method is doing is shoving it in a dictionary here. And look at the client code. The client says add. That's all it's doing. The client didn't, by the way, have to worry about passing the address explicitly and the IDs. The proxy class did all of that. Here's the buffered service. Here's the add method. I'm doing here my hardcore business logic. And then whatever exception happens, I'm going to catch it. And in my final, I'm going to respond. Now look at how I'm doing it. I'm going to construct a calculated response proxy. That's all I'm doing. That's all I'm doing. I don't have to tell it where's the address of the response. I don't have to tell it what security to use, what ID. All of that is done. Handshake through the headers, all of that. Now this is nothing to do with the service bus. It's really just classic WCF programming. But that's actually what it does here. And it goes and responds. OK? Couldn't be simpler than that. So let's launch the client. No, there is no buffer for the client for the response. There's no buffer for the service. None of this. All of this is going to be discovered and thrown away on the fly. And it all derives from the helper classes I showed you before. So let's do that. Let's add 2 and 3 together. So we got this method ID 1, 2, 3. 1, 2, 3, 4. Let's close the client. By the way, one of the things my framework does on the fly is whenever you do debugging of a queued or buffered service, the buffer may contain messages from a previous debug session. And suppose you say, oh, let me start I'm debugging, oh, I should fix it. So you stop debugging, you fix it, you do F5, and it's still there because the messages are still in the buffers. Right? So what my helper classes will do is, in debug mode only, they will execute my purge all and purge all the buffers as you shut down things, just to make sure that you get a fresh debug session next time. So let's launch the host. We'll detect there's a message for it. Yep, here's a message. And as soon as I clicked it, hopefully it responded. So let's just close it and hope it's actually there. Little bit of a delay as it purges its own buffers shutting down. That was the delay we just saw. Let's launch the client. Here's the response. I can go and get it. OK? So that's how you do basically response out of the queue over the service bus. So now I can do some fancy things, right? As you shut it down, now it purges its buffers and so on. So let's launch the client. And let's also launch the host. So here's my application. I'm the user. And I'm just going to do a bunch of things. I'm going to add 2 and 3. And then I'm going to add 22 and 3, and then I'm going to add this and that, and so on. And I can just embellish this scenario to your heart's content and keep doing this. It's all happening in the background on the service. And of course, I could complete them in whichever order, because I'm starting at whichever order. I'm going to be funneling back to the response service. And I can actually go and select things here. And you can see the user interface being updated as these things come along. Let me suggest to you, this is a far better way of using the internet, or web services in general, right? None of these, you have to be connected type A thing, and everybody's to be shooting at each other and such. I'm just typing things on the client, things go to the backend, get processed, come back, I reflect it to the user. Isn't this a little bit better to use a bungee cord instead of a very rigid line, right? Look at the time. Some resources for you. Everything I showed you today, plus much more, is in the 3rd edition of my WCF book. There's a mini CD here with all the demo I showed you, plus much more demos. I think I've got more than 100 demos on the service bus with my utilities and such. The service bus is nothing short of a bottomless pit if you start thinking about the design pattern it offers. And if I had more time, I would show you some other cool things. I discuss it all in the Architects Masterclass. I do these classes once or twice a year. Next time is in November. These classes always sell out months in advance. I stopped even promoting it on the website, because otherwise I get hundreds of people sending me email, I want to get in. So I'm letting you know. It's all word of mouth. This is it. Few departing seconds questions. Good. Thank you all.